we're going to have a look at what's called the product rule. To understand why you'd want to use it, let's just go back to what I said a couple of videos ago when we talked about trying to differentiate something like y equals x squared plus sine x. And we talked about being able to just look up the bits off the table. So x squared, you look up off your formula sheet. It's the standard one, the 2 comes down the front, the power drops by 1. Plus derivative of sine x, look up in your formula sheet, sine x cos x. Okay, so we end up with that. And I said that as long as you only had pluses or minuses in between, you could just do it bit by bit, look up each bit on the formula sheet, and away you went. Now at that stage I said to you that didn't work if you had times or divides in between. So what times if we had x squared times sine x, which any sensible person would write as x squared sine x. You don't need to put the times in there. It's the world's worst math joke. The world's worst ever math joke. I've warned you, so don't, there's been warned, this is the worst ever joke. If there's 2 things with nothing in between them, it's the same in maths as it is in life. They're trying to multiply. I did warn you it was the world's worst ever maths joke. Okay, so here these things got nothing in between them, so they're trying to multiply. The question is, how do we differentiate the sucker? And you can't just do the 2 bits and stick them together with the times. It doesn't work that way. If you start looking at graphs and things, it just doesn't work that way. So what we need is we need a rule, and we call it the product rule, that lets us deal with 2 things multiplied together. So if we have y equals u times v, so there's 2 things joined together, then on your formula sheet, you'll find it says then y dash is u dash v plus u v dash. Okay, so what it's saying is that you need to identify the 2 parts, you need to differentiate each bit, so you've got a u dash and you've got a v dash, and then you need to join them together in this fashion, and it will give you the derivative of the whole thing. So looking at what we've got here, sometimes a wee table is quite helpful doing these. You don't have to, but it can be quite good. So if we've got u and v, and dashes for each one. So this is u and u dash and v dash. Then u is x squared and v is sine x. And all we have to do is look up our table to do the 2 separate parts. So differentiate x squared, we get 2x. Differentiate sine, we get cos. And now it's just a matter of sticking them back together. So our formula tells us it's u dash, it's 2x, I can find that, it's not too hard, times v, that's that one. Oh, and there's a plus. And then u, which is that one, times v dash, which is that one. And we're done. Okay, so that's really all there is to the product rule. It's a matter of identifying that 2 things are stuck together by multiplication, and then working out the derivatives of the 2 separate bits and sticking them together using that formula. So let's have a look at another example. So we did y equals tan x e to the power of x. So I write that around the other way. Not that you need to, but sometimes if you write that, it's confusing as to whether you mean that or not. So let's write it around the right, sensible way. E to the x tan x. Okay, so doing exactly the same thing we did before. You don't need to do this table. After you've done a few of them, you probably get used to doing it without it. So u is e to the power of x, and when you differentiate that, the table tells me we get e to the power of x again. That's quite an easy one. And then we've got tan x, and the table says if we differentiate tan x, we get sec squared x. And then to do the derivative, all you do is stick them together. So the derivative is u dash times v plus u times v dash. Done. And that's all there is to the product rule. So 2 parts multiplied together, call one U and one V, differentiate them each separately, and stick them together using the Poto drill. That's all there is to the Poto drill.